Over the past decades, we have seen an astonishing increase in the bit rate of personal wireless communication systems. Signal and data processing have played a fundamental role in this improvement, enabling the use of new and more effective communication strategies. Could it be advantageous to extend the processing to the electromagnetic field involved in communication? To answer this question, we consider the classic OC layer and extend the model by introducing an additional layer below the physical layer. This further layer will be called the deep physical layer. While at the physical layer level, the communication process is described in terms of bits, at the deep physical layer level, it is described in terms of electromagnetic field configurations. The deep physical layer was introduced for the analysis of the communication process, identifying the physical mechanisms that limit the maximum amount of information that can be reliably transmitted. But, is it possible to go a little further, passing from analysis to control of the communication process at the deep physical layer level? Or, in other words, can we get some advantages by introducing electromagnetic field processing devices, that we will call EPDs? An indication of the potential of field processing at the deep physical level can be provided by ATOM, a device developed as a proof of concept in the early years of this century. The EPD used in ATOM consisted in a set of simple wire antennas, whose scattering properties could be controlled by pin diodes. The EPD was positioned around the transmitting antennas, becoming part of the electromagnetic environment in which the communication system is placed. The EPD status was dynamically selected to maximize the channel capacity of the communication system, using a genetic algorithm. Seen from the deep physical layer, the EPD allows a certain degree of control of the electromagnetic environment, and therefore, of the set of fields on the receiving antenna, while the generic algorithm allows to select the set of distinguishable fields having greater cardinality. Seen from the physical level, the EPD changes the communication channel, while the genetic algorithm allows to identify the one whose channel capacity is higher. But, what is the impact on communication systems? When ATOM was tested in real-world environments, the EPD enabled an average reduction in transmitted power of nearly 50%. This is an indication of the great potential of electromagnetic processing at the deep physical layer level. The ATOM concept was developed at the beginning of this century, when many key technologies for EPD were in their infancy. Today, simple dipoles terminated by pin diodes can be replaced by sophisticated metamaterials to obtain higher flexible EPDs, while the slow genetic algorithms can be substituted by powerful artificial intelligence algorithms, with disruptive improvements in the performance of ATOM devices. More information in this website.